let's take a look at this example. Right now we're supposed to perform the multiplication. In order to visualize how everything is going to work over here, I'm going to convert this prefix to power of 10. And I'm going to have 5 times 10 to the third ohms times 20 times 10 to 0 ohms. Because I have multiplication over here, and over here, I can take off the parentheses and rewrite this problem as 5 times 20, 5 times 20, times 10 to the third times 10 to 0, and ohm times ohm. 5 times 20 is 100. Times, anytime I multiply two numbers with the same base, I have to keep the base and add exponents. That's why I'm going to have 10, and 3 plus 0 gives me 3. Now, if it comes to the unit, we have to do the same thing. Remember, this is the base, and anytime I have no exponent, there is always invisible 1. So this is going to be ohm, because I have to keep the base and add exponents. 1 plus 1 is equal to. I have to express this number in terms of prefix. Okay, so I'm going to have 100, and because I have times 10 to the third, this power of 10 is represented by lowercase letter k. So I'm going to write over here k ohms square. And this is the solution to the problem. Let's take a look at this example, and like always, I'm going to do everything step by step in order to make you understand what's going on with these prefixes, powers of 10, and the units of measure. First, I'm going to convert prefixes to the powers of 10. I have 45, and because I have no prefix, I'm going to write over here times 10 to 0 watts times 20, and instead of milli, I'm going to write times 10 to negative 3 watts, because milli represents 10 to negative 3. And because I have multiplication everywhere, I can take off the parentheses and write this problem as 45 times 20, 45 times 20, times 10 to 0 times 10 to negative 3 times watt times watt, watt times watt. 45 times 20 is 900. Times, anytime I have numbers with the same base multiplied together, I'm supposed to keep the base and add exponents. 0 plus negative 3 is negative 3. Now, if it comes to the units of measure, you're supposed to apply the same rule of exponents, okay? The same property for exponents. You're supposed to keep the base and simply add exponents. 1 plus 1 is equal to. The number on the left side of decimal point is between 1 and 999. The exponent is multiple of 3. That's why I can rewrite this number as 900 milliwatts square. And this is the solution to my problem.